So, welcome to the webinar regarding hints and tricks, some syntax control and so on for Powersim Studio. We have a small agenda this time as well. If you need to ask questions, use chat or talk to me, then I will try to interrupt or collect some of the questions so we can go through them. For dimension consistencies, which is the first point, we will look at using the for function mainly to combine two kinds of dimensions, meaning one dimensional variable by one two-dimensional variable. To do that, we will first look at a single vector containing some cities. So we go to a plain model. In here, looking at this one. So here I start by making a range. I double click global ranges. I right click, say I add an empty range. That's quicker to do than saying add range, because then I can define the range here. I say cities should be Berlin and New York, like that. And of course here I need to use the single quotes when using space in the names. So it prevents me until I've defined it correctly. And now the range is finished. This is quicker and easier than using the wizard that would very much be going into this dialog. But that's what I skipped now. Make it a bit smaller, and I'm ready for the rest of the model. So we go back to share diagrams. Here we can now make a constant. Let me get some space here. We can zoom in a bit. This constant should contain one value for each city. So I say this is, in place of double clicking it and say define, I can just type the equal sign and say that the values of this one should be 2 and 5, for instance. That's the two values, but still I haven't connected it to cities. To do that, I have to enter properties. But so far, I haven't been inside properties, and that's also recommended to use the equal sign. You can do that even in the same process as defining the name of the variable. I don't change the name now. I say here, I want cities, double click there, to be the dimension. Then 1 and 2 became Berlin and New York. One value for each of them. As you know, if I make just the variable here equals 6, for instance, then I'm allowed to multiply these two variables. Now I jump a little bit. You see in this agenda, I have some agenda part here to make quick links, straight links, and so on. Many links in a sequence. I will do the two last points here now. You see, to make both these links now, I want a link from constant 1 to auxiliary 1, constant 2 to auxiliary 1. Then I can double click here. When doing that, after making one link, it still remains a link until I press the escape key or this arrow we have here. So to make this link, I can also hold the control key to make it straight. Holding control key while releasing mouse key, that makes a straight link. Very easy. Holding control. So now I made these two links only touching this button once. Then escape gives me back the normal cursor. Very easy. In here I double click because I want to use these ones. And I want constant 1 multiplied by constant 2. I normally use a space here, but that's not necessary in most cases. So now you see I have this variable and this one. Here comes another small hint that could be useful if you want to be a little bit quicker than other times. Then I want to select both these variables and I want to make auto reports. Then after selecting all but the last one, I can hold Shift now while selecting or deselecting variables. When I come to the last one, I press directly on the right mouse button. Now I do not press left mouse button here, I press right mouse button and show auto report, and I have the auto report on both these or all the variables I had selected. So you don't need first to select left mouse button, then selecting right one afterwards. You save a little bit of time on that. So as you see here, there's no problem of combining one dimension with 0 dimensions. This is fine. It's calculated automatically. I now need to deselect to select this one. This multiplication detects that this one has 1 dimension, and it's allowed to multiply that by 0 dimensions. Okay, that gives result cities. I have not chosen cities as dimensions here. That comes automatically. Another thing I'm allowed to do is if this one is also cities, like this. Now both of the elements are 6, so it's no difference in result, but also this is allowed automatically. What is not allowed is if each of these cities has a vector, meaning this variable becomes an array. So I say here that I want 2 elements. Let's make some empty space there. Each element, each of those cities should be a small array. I put 1, 2, 3 in one of the arrays. Next one, I do similar. Put 4, 3, 2, for instance. Now it says this doesn't match cities because I have 3 dimensions in the second one. So I say I have 1 to 3 there. I could also, if I was uncertain, I could have clicked automatic and then change 1 to 2 to cities. When doing that, then you see this one becomes undefined because we are not allowed to do this. Many people, they ask, why are we not, or why couldn't it have detected this? Because we have 1 value for each city here, and here we have 1 vector for each city. Isn't this the same situation as we had, just with 1 more order or level of the dimensions? Well, yes, it is. But the reason for this one not to be calculated automatically is that in some cases, if we after a while change the second dimension to cities, for instance, then it would be unpredictable of which dimension to be used in this automatic detection. So therefore, you have to use a for function in a situation like this. I want the value 2 to be multiplied by these values and 5 to be multiplied by the other ones. So to do that, there are many ways of doing it. I will show 3 of them. The first one is the kind of rule of thumb, the safe way of making this for function. Because we know that we want the result of this one to be the same dimensions as this constant 2, meaning it has cities as the first dimension, then 3 numerical values on the second one. So we type 4. Inside the 4, if hovering it, you see we need dimensions, then this tile and expression. The reason for using a tile between dimensions and expression is that you may have several dimensions separated by comma, as we will have now, and it's important that those are not being handled as other parameters. So we say here C, for instance, equals cities. That's the first dimension we want as result. Then a comma. It's not a new parameter because we haven't put the tile yet. So the other dimension, just an index, equals 1 to 3. Then comes the tile, and we are ready for the remains of the definition. No, actually I'm forgetting myself here. I don't want any line breaks here, because that's one of my points later for the missing brackets. But here now, still I'm trying to combine constant 1 by constant 2, and that's something we are not allowed to do. So this error message tells about this one. So I have to pick out some elements from this constant 1. And from constant 1, I have cities, as I see here. So there I need to use the C index variable. On constant 2, you see now I get many dimensions here. That's normally a sign that I have forgotten some indices at the end of the variable. Cities and index. Now you see I got a result here as desired. 1 times 2 is 2, and so on. 3 times 2 is 6, you see. 3 times 5 is 15, and so on. All these ones are calculated according to the different variables. This is actually enough. This is what you need to do when you want to multiply values like this. Of course, this variable could have been only this second dimension, 1 to 3. It would still work. You could have made this dimension like this anyway. But this is kind of the most normal situation you have. Maybe the situation would be that the index had been here and the single dimension would be cities, perhaps, but the syntax is the same. So now I want to show 2 other alternatives of this one. So I make some copies of it, and now again I want to show you how easy it is to copy a variable. You could use copy paste, but you can also just move it like you do with a file in your Windows Explorer. Just move it, hold the control key before releasing the mouse button. Then we made a copy. I make another copy because I want 2 alternatives here. So I make all those variables, and now I need links from these 2 variables to these 2 ones. For new links, then of course it's very useful to double click here, and I make these links, and it's very quickly done. So after making the links, then I'm ready to do the changes here. One of the changes is a simplification of this one, because as I said, a rule of thumb and the safe way is to define in the for loop or for function all the dimensions you want. But as you saw before I entered these ones, let me show again. If you remove those, then you see it adds more dimensions to the result of this function. Because now for each city and index, I'm adding a constant that contains 2 dimensions. So therefore, I get cities and 1 to 3 over again because they are implicit in this variable. So for each of these 6 values I have in the 2 first dimensions, I now get 6 more values, which is not the intention. It's a mess, you see. I get 4 dimensions. But that can also be utilized. That can be used if I now say I only want to pick the city dimension there. Now you see it's only the index, the 1 to 3, which is being put in twice. And that may be exactly what I want. So then I can skip this one. I say the for function only goes over cities. So for each city, let's see what's happening here now in this equation. Each city, for instance, Berlin, 2 times constant 2 of C. That is, constant 2 is this variable. C is now Berlin, and that is a vector. So in this case, I actually multiply one single value by a vector, which is 1, 2, 3. Very useful that it is added, but sometimes it is maybe difficult to understand. So my recommendation when doing this is to emphasize that here we have the dimension as the second one here. The added dimension comes from this variable. It could have come from both of them, but in this case it comes from one. So now it's a bit easier to read, and it's of course still the same result. If you show this auto report, you see we have the same result. The other way of doing this is to skip the other one. If I skip cities, then the cities will be automatically added if I remove these ones. So here as well, I could remove the entire indexing like that. On this one, I can't remove it, so I have to use the star to indicate that there's another dimension here. So this one works. That's kind of the minimum you could have. I see there are some questions. I'll come back to those. I'll finish here. This constant one, also here, I recommend putting the star so people reading this equation can see that this is, here we have some more dimensions, and here we have a dimension, and here it's the first one, so that one can't be skipped. We have to use the star in this case. So the only thing now is that the cities comes afterwards. Otherwise, we have the same values. So the order of these dimensions are switched. Now 2, 4, and 6. We now have here 2, 4, and 6 on those. So back to the question from Pavel. I see you posted to everyone. That's very nice. Difference in syntax writing or constant? Oh yeah, if there's a difference. No, actually I don't think so. But normally, I don't. Let's take this first one. You ask if there's a difference of doing it like this or doing it like this. You see, we get the same result, and everything is the same. I will not recommend this way, and I don't think there's any difference, not in speed or anything. But if there is a difference, I think this one is slower to index it twice, because it will have to read the indices 2 times. But there's no problem in doing that. You can also index the result of a function. For instance, if you take this result now, you see this is a result of some cities and the indices. If I want to, I'm not 100% sure, but I think I could type Berlin here. Yeah, I can. Now you see I only get the Berlin value, 2, 4, and 6, because I have indexed an array. So if it is the result of a function or the result of another lookup like we have here, constant 2 of C, which will be Berlin, and otherwise it will still work. So I wonder, you have mentioned also that the first method is the only one that will work correctly. I think you can use both, but again, I don't recommend doing this. At least it doesn't make any sense to do it like that. I think it's more readable to put a comma in between there, like that, and you get the same result. But now, as you see, this equation, let's say I want to pick out Berlin from this one. Oh yeah, matrix algebra operations. Yeah, operators. Yeah, of course you could do a matrix product, for instance. This is let me show you that as well. If you want the matrix product of 2, you use a hash sign before the multiplication, for instance. So let's show that, since we have 2 matrices here now. If actually I need to remove the Berlin, I take this one and I go back. I would like to go back on this equation. But before doing that, sometimes if I had forgotten this bracket, for instance, this is a typical case. In this case, it expects the end at once because we don't have anything. But in cases where you have some for loops, some multiplications, maybe several lookups and so on, I recommend putting indents and new lines on your equations. And in this case, if I want a new line here, I guess you all know that you need to hold control to get a new line. If you just press enter, you will press the default button, which is apply. So if I now press enter here, you see I get this error message that I can't continue here because I've finished all the dimensions. So it asks me, do I want to continue anyway? If I press yes, then I store this variable. So I get this unknown sign on it, but I have stored it. Maybe I know this will work later because I want to add another city dimension to this constant. But in this case, I want a new line on this one. Then I indent it. And then I see on top of this one that the for function is now the next one to end. So I go here, I know that's the end. So that's where I put the ending bracket. And by doing that, you see, then it's easy to verify. And even if these brackets are not on top of each other, I think this is a good way of formatting your equations. Because inside here now, you could put anything, which has another formatting, and you could nest it and nest it and nest it inside each other. So you easily keep record of where to put the extra brackets or missing brackets, or maybe you have excessive brackets, so you need to remove someone. That's very easy to do if you organize it like this. Some people, they still think they like putting this on a new line, but they want to keep the ending bracket at the end of the last line. That's also possible, of course, because you have this boldness of the bracket you are focusing on. So it's pretty easy also then. But my personal meaning is that it's nice to keep the ending bracket under the start of the function, even if you're wasting one more line in many cases, because the ending bracket will be the only content of that line. Some people are wasting even more, putting both the start and the ending bracket on separate lines. Then of course you have absolutely full control. When it comes to parameters, you could say in the for function, I normally put the dimensions on the same line. But some people, they like to put that on a separate line. And if they do so, then it should be indented. And then I prefer having this tile on a separate line. So you really see that is one parameter, that is, or one part you could say, and that is one part. And if these are very complex, you could put them on separate lines as well. As long as it's like this, organized, then you easily see where the breaks go and so on. So that's very useful. Then back to this one. I've removed the Berlin now. So we have a matrix here. Let's take this one and multiply it by 2, just to have some other values. And I want the matrix product of these two in, if I can do that. Maybe I need to add one more city, but let's see if that works. If I combine these two here, you see, if I just take one and multiply by the other, then it multiplies each element. And that may not be what I want. 2 times 4 is 8, and so on. It's made like this on purpose because that's what most people in most cases want. But if you want a matrix product of those two matrices, then you can use this hash sign like that. And of course, we need to, I think, let me add one more city here. I add Oslo. Like this, and then I need to go in here and add a value for Oslo, 4, and I add a vector for Oslo here, like that. And still we can't do it. Let's use cities also on the second one. So now I come into the situation we had where it would have been silly to do this automatically now. Which one should be calculated? Should this one be calculated on this dimension or this dimension? But now you see these two matrices, they make sense to make the matrix product. So here you see we do not have 2 times 4 is 8. That's not the value here. It is the real matrix product we have, simply by using this operator and not the single star as multiplicator. So matrix product is here. In an upcoming new release of Powersim Studio, there we will introduce custom functions, and one of the example functions is actually the matrix product. So there we demonstrate the difference between using this operator and using the matrix product directly. So this is a nice thing. Then back to this one. Here you see I also need cities here now. No problem in doing that. And you see we get, even now when I change to cities, it is even more readable that you get a different result. Let me remove this multiplied by 2. I want the same result here as in this one, but because I have skipped or automatically added the other dimension, you see it's the first dimension in this one I'm adding automatically, then I get a transposed result. So the cities being added here, this last one, that is the city dimension we have in constant 1 and the first dimension of constant 2. So if I want the exact same result after skipping the other part, then I can simply use a transpose function. So now you see, for instance, 16 here is on the opposite side of the matrix in this version. And let's say this is what I want. So we simply put transpose. Now I feel the need of indenting this to be able to see where we are. 4 and there, and transpose and there. So now you see we're back to the same result. this one and this one gives the same result. In here, I am skipping the first dimension, meaning the first dimension in constant 2 is added to the end, and opposite. So that's what we get here. Okay, now I escaped it. Yeah, that's fine. Okay. So if no more questions to that, I have now covered this, how dimensions are added automatically. If you just put a vector or a matrix as part of an existing for function, then you get the last dimension automatically. Makes it, in many cases, much easier to make the definitions. It may be a bit difficult to read it. Missing brackets, I suggest using line breaks and indents. I suggest the same for Excel. You can do it in Excel, but it's not very normal to do it because you have this small box up there, but that one will expand in Excel. And in Excel, I don't think you use Control Enter, but you use Alt Enter or Shift Enter. I think it's Alt Enter to get a new line in Excel. Then to stocks and flows. The first point here is how to make sure the unit match up if you're adding them. And then we need a reason to add them. So I would like to make a small example on that. Let me take another diagram for that. We have a level here with some inflow. Last time I used a random function here. Let's say we have 3 people per day. People is red because it's not defined yet. So I define people, one person as atomic. Then I initiate it to, or let's say to 100 people. Like that. So far, this is a simple model. I can make a graph here, and we simulate going from 100 to 1180, adding 3 people every day. From this level, let's say this is the population. So from this one, I want some outflows. One outflow is typically deaths. Deaths like that. And I say the deaths would normally contain a death rate and so on. I just put that directly in the definition here now. So I say it is the population multiplied by 90%, and that is the death every day. It's a very high death rate. It could be flies or something, this 1 day fly, like this. So now you see the model still works fine. If I run one step now, you see 3 people will come in, 1062 will leave in this step. Then I'm left with 100 people again. Now 3 people comes in, 90 out, I'm left with 13 people, and so on. The amount of people is reduced until it stabilizes. So you see the curve here went from 100 down to almost nothing, but it stays there. Then I have another outflow. I have some emigration. I do it the same way there. Let me copy this one. not 90%, but let's say 30% do emigrate. I reset the model. And you see, 3 people in will give 103. The deaths gives 90 people per day. Immigration, 30 people per day. If I go one step now, I get a negative number here. So now we have a very good reason of looking at, for instance, for emigration, we don't want to emigrate those already who have died here. So therefore, we need a link from one of the rates to the other. And this is kind of, now we have a question, how do we subtract these deaths from the population and keep the units intact? You see here, the population is what we should do something with. So I put that on a separate line and the multiplication on another one. This population here, I want to subtract my deaths like this. Now we get an error message saying that we have a conflict of people per day and people. And in this case, we may wonder what is the correct thing to do here. In some cases, it would be correct to multiply this by 1 day. In other cases, you need to multiply by time step. And the difference between those may be a bit difficult. I suggest you should, it depends on, are these discrete flows or continuous flows or combinations of that. And what is the reason for doing this connection? Is it because you have inaccuracies in your simulation, or is it because of other reasons? So first, before doing that, I remove this again. I will just show you this negative situation. You see it goes up and down and it stabilizes and so on, but we did really not want that dip going down to -17. If we go in here and reduce the time steps, this one from 1 day to a fraction of a day, like this. And now again, we run 1 step. You see, we didn't go below 0. It just went a little bit down. So now actually this model works fine without any connection between here. If I just continue running, you see we have almost the same shape of the curve. It goes down, it's stabilized on 2.5 people, and we stay there. So in this case, actually what we are dealing with is the inaccuracy because of 2 large time steps. If going back here, I would think in this case it's best to multiply deaths by the time step, because that's what's done here in population. If you look at not the initial value, which we have by default, but on the flows, you can see the different connected flows. So you see we have 3 flows on this one. It's 1, 2, and 3 flows. The minus flows are outflows. The plus is the inflow. So deaths and all the others are multiplied by dt because these are continuous flows. So therefore, when it comes to inaccuracies, it may be correct to use time step. Otherwise, it may be correct to use 1 day. So you should try that when doing it. But the point here is you need to multiply this one by some time if you want to make them addable or subtractable. And that's what we've done here. And the reason for using time step is because it is multiplied by time step in the population to handle large time steps and small time steps. So now this one will work without going negative and without using reservoirs or anything like that. It will work regardless of your time steps, the large or small time steps. Okay. So I just continue here. Yeah. Of course, there is an exception of using this. If your defs had been a discrete flow for some reason. Now I do what I absolutely shouldn't do, but if I do not divide by 1 day here and say that this is a zero order, then I should absolutely have, some condition here saying that they are dying, for instance, on a certain condition or something at the end of the year, whatever. If you have an outflow like that, then you can defend using this zero order. Now I'm doing it the wrong way. I say on every time step, regardless if the time step is 1 day or 1 week, I remove 90% of those people inside here. Then you see this one is not defined because then we shouldn't multiply the time step. Now it works again. So now the model works fine, but I would get a different result if, for instance, increasing my time steps now. If I go up to 32 days and run it, you see I even got oscillations because it's not, it's too large. I have too much emigration, but you see the result is also very different for regarding the deaths. If we look locally at those, because now I'm removing 90% on every 32 days and not on every day. So that's a big difference. So discrete flows, you should have an if normally on those. So I go back on this to emphasize what is most interesting here. You have continuous flows, then you multiply by time when you need to combine this. Then we come to another way of combining them. So I save this now. Let me webinar like this. I want to add or just show another function that could be very useful to use in cases like this. Because if you want emigration to be only one value, but for some reason you want the deaths to be one death for females and one for males, for instance. So if we add an array here saying 90% for one element and 70% for the other, like this, now you see we got 90 and 70%. I still only have one value here, 100 people. What will happen? Let me go back to 1 day. Yeah, I have that there. Now 90 plus 70 people will leave here. So you see, or actually I should remove it, but the point is both of these are subtracted from the population. Don't look at the negative value now. The point is I do some calculation here. Another thing I get is that I do not want emigration to be split in 2 values. I want only 1 value here, but I want to take the deaths into account. Then I could use another function. That function is called resultant flow. So in place of having that link going between those, I put 2 new links, remove that one, and I say this one should be, actually I need a link from the level as well. and I say resultant flow of, you always get help by hovering the mouse on the function, level and variable. Level is population, variable is deaths. To do that, I need to enable some features in feature pack 3 of Studio 9. Therefore, I will save this file on another file name and send you both the files in case you don't have the Studio 10 yet. So I do that now. Here you see I get a value here saying minus 160 people per day. Why do I get only one single value here? Well, that's because that's this inflation on this level. Let me remove or reduce this these values a bit. I go down to 10% and 70%. Still, I'm reducing 80 people per day, the sum of those. Where is this sum made? Why do I get the sum here and not an array with 2 elements? Before I relieve, I guess most of you know, but before I say that, I fix this one. I use this auxiliary free in place of the variable directly. Then you see I'm left with 54 people leaving because of the emigration. So, oh sorry, that's one more thing we need to remember when using resultant flow is that it should always be added, because the fact that this is an outflow is also taken into account there. So it's 6 people, that's more correct on the emigration. That's the one left after the deaths and a fraction of the ones left. Then we have 6 people. So back to the question, why is this one reduced with one single value? That is simply because now in the flow definition, not the initial one, but flow, here you see, because deaths is a vector and this level pop, that is one scalar value. Because of that, this collect function is added automatically. You could to some extent change this yourself, but we don't recommend doing that. This is the automatic and the only logical thing to do here. It's very similar to the array sum, but it may filter out some dimensions in case you have several dimensions here. So that's why it's not the array sum being used, but the collect function. And since these ones are collected, that's regardless of this resultant flow variable. They're always using this collect function. And that's then one of the benefits in this resultant flow, that we can see what is the effect of this variable on this level. If I make another level, let's copy this one over here. And I connect it. This copy of the population, I put 2 values, 100 and 9, for instance, like that. And I also copied that one. So deaths to this one here. See, this is resultant flow of the copy of population and deaths. The difference between the copy of population and the population is that this copy, it has one dimension. So then, of course, the effect of the same death variable on this value is, I need to reset the simulation to initiate the function. Then you see we have the effect 10 and 70, same as we have here. That's about to be added to this copy of the population. while we subtract 80 from the population, since the population is a scalar value. And using this variable in any other flows, then you can easily keep the order of what flow to be calculated first. This is even more useful if you're making an aging chain. An aging chain would typically be making a flow going out and into the same vector level. And then if this chain has one element less, it will automatically move from one element to the next one. That's another story. But if you do that, it's pretty complex what is happening inside these functions here. Then you have prefix 0, suffix 0, and so on. And that is difficult to take into account when you have values like immigration and so on. So that's why this resultant flow has been made to handle functions like collect front, suffix 0, prefix 0, and fill in zeros. All those are functions. You may wonder how to recalculate this. Well, you don't need to recalculate them anymore. After the feature pack 3 on Studio 9, this can be calculated by using this function. So that's very nice. Okay, so I saved this on another name because this is 9.3. It's a feature pack 9.3. I call it 9.3 on that one, and I go back to the previous file we had, where we do not use that function. Then you can all read the values. Okay. So, if no questions to that one, we have now covered the different cases of stocks and flows, discrete flows, and how to create links and so on quickly. We have done 2 of these 3. The last one I wanted to show is if you're making one link somewhere, let's say this link is missing and you want to make it, then in place of clicking this one, you can use Control 5. That is pretty useful sometimes especially if you make many links between submodels, then you may do some bindings and so in between each link. So then it doesn't have to double click it. So simply, now I have the arrow, I press Control 5, then I can make this one. I make one of them, of course I can use Control as well here, and make it, and then it's finished. I have to press Control 5 again. That's pretty quick, but I still prefer double clicking if doing it with normal variables. Okay. So, next point here is something many people ask about, or at least on workshops and so on. If you make multi-selections, then you may have some struggling because it is deselecting variables you don't want to deselect. So I will show on this one, for instance. Let's say now this had been a much more complex model, and I want to select almost all of it except this part here. Then, of course, one way of doing that is to select all, like this. I drag a square around it. Then I can hold Shift and drag a square around what I want to deselect. Now I've deselected that. And for instance, I want to make a shortcut to these ones. That comes in the next part of the agenda, but I can, for instance, do this and hold Shift Control. Then I made lots of shortcuts of those variables. So you see all of these are shortcuts. Maybe I want to use them somewhere. But in some cases, in place of utilizing this fact that you can deselect like that, that may be something preventing you from selecting properly. Because you can't select all, there are other reasons for not being able to select all. So you need to start by selecting this part. Then you want to select this part here. So you hold shift. Let me zoom out a bit. You hold shift and you make this selection. Now when releasing the mouse button, you see these two were selected, but those were selected already. They are deselected, same way as I used it to deselect this one. So I have deselected those, and maybe I can do it a third time. So I do it here, but then I deselected this one again, and so on. I need to struggle a bit before I have selected all I want. But there is a way to select and just add, not deselect at all. And it is as simple as, now if I now hold shift button, I select this, but before releasing the mouse button, then I release shift. Now I release the shift button, then release the mouse button, and you see it only adds to the selection. Very useful and important to keep in mind. So that's a hint, and I find it very useful. I use that one very often, but it's difficult to find that information in the help, even if it's written somewhere. I'm not sure where. So keep that in mind. Shift select, and release button before releasing mouse button. That's very easy. Okay. Then we come to shortcuts. We get a little bit over time, but these shortcuts are very nice. I've already shown you how to make shortcuts by holding shift and control. Then we can make a shortcut of a variable like this. A shortcut means that you have the usage of a variable. You can show the auto report of a variable on other locations, also in other diagrams. If I want to use auxiliary 2 in diagram 2, I kind of move it here, but I hold shift and control before releasing mouse button. Then I have the variable here and can connect it to variables inside here. So another way or safer way of making a shortcut is to use the right mouse button. If you use the right mouse button, moving it here, then I get the choices. Do I want to copy it, move it, or create shortcut? If I create shortcut, then I did the same as I had here. Also this one, I can show the auto report, or I can double click it, but I don't get the definition. I only get the documentation, dimensions, and so on. But if I still want to edit it, I have two ways of doing that. I could click this edit variable button, then I come in to this definition, but I could also say, I think maybe it says, no, it doesn't say in, it says here, if you forget this shortcut, there you see Control E can be used to edit this variable. So if you click it, then type Control E, then you're able pretty easily to change the definition also of a shortcut. Many people have asked about that, since in previous versions it was possible to double click the shortcut and edit the variable. The reason for removing that is that many people got confused about where is the original of this variable. And now we have to go to the original or a slice, which means it could have several originals, just as before, but then it's now called slices. I will show that as well. If I do the same thing, right click and move it into another diagram like this, then you see I have this choice. I didn't have that one moving it within the diagram because slices can only be moved to other diagrams or be used in other diagrams. If I create a slice of this auxiliary, first of all, I get a yellow mark saying this one shouldn't be a slice. It should be converted to a shortcut, because some old models, if you convert them, then you may have many slices like this. So you have a choice on the diagram menu. It says here in this tip saying that you could convert all slices to shortcuts. If choosing this one, it asks me where do I want to do it, in what order, and so on, because you may have several slices of one variable, but it's pretty logical. So I recommend doing this if you have slices in your model. But the reason for using a slice is that you may want to have some input to a variable from several diagrams. You could also use it to make simplified additions or kind of user interface versions of your model, where you remove most of the variables but just keep the central ones. Almost like a causal loop diagram, but still with variables, and you can use auto reports and so on. That could be very useful. So in this case, you see here, population is now an input to this variable in addition to the others. Only one link here, two other links are located here. So that's one possible usage of it. If I double click here, you see population is still possible to put in. So if I take this matrix product, multiply by this population, and I get a strange combination of these ones, but that works fine. So I get some large values. This is now dependent on the other one. So if I run the model, you see these ones are changing over time because it's using variables from another one. So it's smart looking at the slice. If there's a slice, there may be other inputs to the variable. And then, of course, this yellow mark is also removed because you may have a reason to using it like this. Okay. One other way of creating a shortcut is to use the begin link here. And a shortcut could have many purposes. One purpose is to reach a variable in another diagram, but shortcuts within the same diagram is useful if the links are too long. In this case, for instance, maybe this longest link here, it's annoying, I think. Then, of course, I could make a shortcut of this variable. I move it using left mouse button, hold Control-Shift, release it. Then I delete the previous link, because if I don't do that, if I try to put the link here, then you see that's not possible because the link is already there. So I end up with some spaghetti and I just have to abort it. I have to remove this one, then I'm able to put this link. And I have saved the possible spaghetti tracts going from this one. But now I undo this because I want to show the easier way. The begin link here is simply, if you have a long link, you simply right-click it there, for instance, right-click and say begin link here. Then it do all this operation. Then it removes original links. It makes a new link from a new shortcut to that variable. Then I can position it where I want. Maybe I want to do it with this one as well. In general, I recommend not using shortcuts, especially not in feedback loops. If you start using shortcuts in a feedback loop, then you don't see the feedback loop anymore. So it's that's the thing. I see there's another question about avoiding the time delay added. Yes. Oh yeah, sorry, I forgot that. And that's of course that is also a purpose of using these functions. Resultant flow. I will not use resultant flow now because I want the old file format of this one, but it's the same thing. If looking at the table here, I only have one moment left or one item left of the other one, but I'll come back to that one afterwards. It's very quick looking at this. The rate and the population here. Let's disconnect these two flows. And I make a small table, time table here. in this timetable, I put the rate, that could be births, like that, and the population. When looking now at these ones, I reset the model and I start running it. Oh yeah, I want all time steps. And this one, I reset, and I go step by step. Then, of course, I should have some varying values here. So I say I use the round function on a random multiplied by let's say 30 people per day, and I round it to 1 person per day. So I round this value to, I don't use indents, I missed it a bit here. Now I get different values here on each day. So we go back to this one. Now when you look here, these 26, they got available in my population 1 step later. So in all flows like this, we have a delay, and in some cases we may need this delay. You see, now we have 126 people. The 21 people we have here now being born, we don't see them until the next day. We have something called immediate flow, but we don't recommend using that. That's in very special cases that we use that one, because then you kind of hide the value as it goes through. So we recommend using the same adding purpose here as you need here. And in that case, then there's no question. Then or it's more rarely a question. So we could call it population available. If we want the population available, for instance, for use with the deaths, I'll show that afterwards. Population available is the population plus the population, plus the births. And you see this is not possible because I need to multiply it by time step. Like this, because it is multiplied by time step inside here. Births times dt. dt is time step. So my population available, let's put that as well in here. Reset the model. And then you see the births coming in. 6 births, they are already there. So it's as simple as that. That's the meaning of that point in the agenda. If using this value rather than that one, you see we won't have the delay. This one, it's not a delayed version of that one, but it's the opposite. It's looking ahead in time actually, avoiding this delay we have in all flows and stocks. From all flows, there will be 1 time step delay. And in feedback loops, for instance, we need that delay to some extent. We can't say in a bank account that the interest should be calculated on behalf of the value exactly now. We can't add that value as well now. We have to add it on the next time step. That's why we have time steps. So there we couldn't use a value like this. But in this model, for instance, we want this varying value we have here. We want that one to have effect immediately on the deaths. So if doing that, we put the link to deaths from that one in place. Same to the emigration, and we delete these links because this is actually a population we have available. So we use that one rather than the other one. And reconnect these flows. and we have a working model. So now when continuing here, going step by step, you see the population do not go below 0, even if now we have more people emigrating and dying, but still it doesn't go out because the deaths here are being handled. So let's see if we get here, for instance, we have a very small value, and even if we have a small value coming in and a small value in the population, this is taken care of in the flows going out because we are avoiding this time delay we get in this part of the model. And this could lead to other parts and so on. And we could have a feedback if we have at least one level containing delay in or one combination of flow and level that gives a delay. That could be used in a feedback. So this is a very common way of doing it, and it's the same kind of situation as we have here. But also in this case, you could consider multiplying by a fixed time constant here rather than time step. It depends a bit on the purpose of the model. So easiest is to test it out, test it with different lengths of the time step and with different, test it both with time step as a factor and 1 day, for instance, in this case, since we are using 1 day on the denominator here. So you should normally, when changing the length of the time step, you should have approximate the same result of the model, especially if you go very low on the time step. Let's say you reduce it to 1,000 of a day. Then if you're reducing it to 1/10,000 of a day, you should have the same result. But if you increase it in this case to 2 days, then you may expect having a different result if you continue increasing it to 4 days. Then you would probably have oscillations, but even if not having oscillations, that is too large time steps. So then other delays in the model may have too much influence. Okay. Oh yeah, and of course we can do non-system dynamics modeling as well. All these, there are many deviations, many kinds of deviations that may not, even using arrays is actually a bit non-system dynamic, but it's very useful in many cases, and many models are impossible to make without utilizing arrays. And it's many of these deviations are also combinable with system dynamics thinking, even if you deviate a little bit from some rules in the system dynamics. But I'm not a very expert on system dynamics. So back to the last point we have here, the ref functions. You automatically get a ref function in a connection between submodel and the main model. A ref function is very similar to a shortcut. When I make a shortcut here, you see I have the value of this auxiliary 2 available for other needs. I could make a link from this one. If I make a variable, let's make a new one. I make it here, new diagram. This is a constant. I give it the value 8 and I put the unit liters on it. Yes, I create liters. It suggests this one. So then I make another constant here. And I say this constant is a reference to this constant 3. What am I doing now? Oh yeah, this also requires a new file format. Did I change it now? Let me verify that. Compatibility. I'm still on Studio 9. So I save this file, then I can mess it up. I say ref of this constant free. Yes, I increase the file format. Now you see I have this special symbol here. So it says this constant defines this one. If I put them like this, you see both of them are equal. But what I've done now is to say that this variable, it shares the memory with constant free. So they actually use the same memory. If I make a slider here on this one, normally that wouldn't work on the initial time step. But in this case, it works because they share the memory. And this also works across submodels. Very, very useful. So I can put a reference into a variable inside the submodel. Inside here, for instance, I say I put a variable here, and this one is public. Like this, I go back to root model. I connect this one in there, connect it to constant 1 inside that one. I go into this submodel, and you see here the value is 754. I can make a slider here, change it to 144. If I go back here now, you see all these variables, they are 144. They all share the same memory. And maybe I want to say this one should be measured in gallons. I make gallons. That's derived from liters with factor of 4.12. I'm sure that's wrong. I should have known that, but like this. Now you see 8 liters, 194 gallon. Yeah, now I can make constants here, or make sliders. I mean, you see they're now working independently. Maybe the one inside the submodel here, that should be measured in cubic meters. Sorry, yeah, I need a third one, of course. I should have done it another way, but that one, cubic meters. So I say 0. Or 2 cubic meters. Going back here, you see that's 2,000 liters, 485 gallons. And I can, of course, put tables as well. Put that value in there, that one in there. If I wonder what is 400 gallons, it will automatically show it here. And I can edit this one as well. 3,000 liters, 700 gallons. Very simple. So that's it. Any more questions? Or anything I've missed? I've been jumping a bit in this agenda now. But I will send all of you this file, which I save as VM 9, or I think this is file format 10. I put it as 10, and so on. So, if no more questions, several topics, yeah. Anything Studio cannot do? No. Nothing it cannot do. Maybe a bit inconvenient if you really wanted to squeeze the limits. But yeah, we are. It's very fun working with Studio, and these new features and the upcoming custom functions are also very interesting. We are looking forward to the next release, and we will make sure that the custom functions will be possible to change for everyone. So So it will not, we have found a free compiler, so you can download it. It will be shown or listed in a help file how you can download and install a compiler so you can make your own functions. We have some test functions, so you can use them as a reference and change them, because there's always some functions, some resources, some this and some that you need to do C++ programming. But it's also possible to change it. You can compile it yourself, make one small change. For instance, take one of the example functions. We have a quadratic formula, for instance, calculating that can easily be done in a normal definition. But we also have a test model, so you can test it. And then you can make your own formula. For instance, if you want to do something iterative, then it's very useful using the custom functions. So that's what we are missing in the current version of Studio. And so we're looking forward for that. So thanks a lot for listening to this webinar. The next one will be after the summer. So we'll give more information about that on the web. So have a nice day and a nice summer. We'll have summer vacation now in 2 weeks from now, so we look forward to that. So have a nice day. Goodbye.